Year 2050, the silent ocean. An ocean that once breathed is now nothing but an archive hole. The new generation hears the sea's tales through digital glass. They've never felt the water's true ripple. So, who authorized this silent collapse?
I'm Zeynep Mihmaş Şahin. I'm also 14 years old. I'm responsible for marketing and website design. I work on how we share our project with the world and raise awareness about our mission.
Hello, my name is Nurdeniz Ocak. I'm 15 years old and I'm the leader of our team. I work on artificial intelligence and software development. I focus on creating smart solutions with technology to help protect our environment.
I'm Melek Naz Yüksel and I'm 14 years old. In our project, I work on 3D modeling and system design. I help create realistic prototypes and make sure that our ideas can work in real life.
So why did we choose this team? We choose Life Below Water and Life on Land team because our project aims to protect ecosystems and living creatures.
While maritime transportation is the most economical way of moving goods around the world, it also carries a hidden threat: biological invasions caused by ballast water. So why did we choose to tackle this issue and how did we develop our solution? Let us explain.
Let's begin by understanding what transportation is. Transportation or logistics refers to the system that enables the movement of people or goods. Among various kinds of transportation methods, maritime transport has several advantages over the other forms. It's 3.5 times economical than rail, 7 times more cost-effective than road, and 14 times more economical than air transport. This underscores its dominance in the global transportation market. However, maritime transport also contributes to marine pollution, particularly through ballast water usage. But what exactly is ballast water and why is its management important?
Ballast is the material used by ships to maintain their stability, maneuverability, and structural integrity. Ships use ballast water to maintain their structure while carrying cargo, storing seawater in designated compartments. Marine species have been confined to specific regions due to geographical barriers. However, human activities like maritime transport have disrupted this natural distribution. When ballast water is exchanged near coastal areas or in ports, it can lead to the extinction of native species or the introduction of invasive species that threaten local ecosystem. To put into perspective, approximately 5 billion tons of ballast water are transferred globally each year, relocating and endangering around 7,000 different marine species. The species shown in the visual have caused significant harm to local population and human activities in Turkey and around the world.
The most common method currently used is filtration, but is often avoided due to the time it requires and high cost of cleaning. Other treatment methods like UV radiation, chemical treatments, heating, the oxygenation, and electrochlorination. However, it's important to note that discharge of chemical treated dead organisms also contributes to pollution by marine ecosystem, further disturbing the balance. With the increasing intensity of maritime trade, what's being done to address this problem? One of the first global initiatives is Sustainable Development Goals. Our project aligns with the 6th, 15th, and especially 14th goal of United Nations Development Programme. Additionally, international organizations like International Maritime Organization play a crucial role. The Ballast Water Management Convention and the OSPAR Commission are key protocols guiding our work, setting regulations on ballast water exchange and treatment in maritime transport.
So what is our solution for the biological genocide and invasion caused by global ballast water intake? Our approach prevents marine organisms from entering ballast water intake points by creating conditions these organisms perceive as dangerous, prompting them to get away without any harm. We understand that ecosystems are diverse, leading to different adaptations in marine organisms.
Therefore, our system is designed to be versatile, using methods such as magnetic barriers, ultrasonic barriers, artificial current barriers, and AI-controlled water intake motors to warn and repel a wide variety of organisms. We employ ultrasonic sound waves with a frequency greater than 20 kHz, using a 40 kHz transducer in our system. Our research indicated that some marine organisms can detect these frequencies. In our experiments with zebrafish, we observed that after activating the transducer, the fish moved away, indicating that they perceived the change. Another component of our system is the generation of randomly arranged magnetic files. Since marine organisms use the Earth's geomagnetic field for navigation, we hypothesized that random magnetic fields could repel them. Additionally, we implemented a hydrodynamic effect created by the ship to repel passive and small organisms not affected by the first two systems. This is done by directing water currents in opposite directions near the ship. Because it is not feasible to find a solution that impacts the entire ecosystem, we developed an AI-supported camera module. This camera stops the ballast tank intake motor when it detects a marine organism.
To evaluate our system, we designed a prototype and conducted experiments.
We use zebrafish for experimental purposes. This way, we researched the effectiveness of the methods we used and designed the system accordingly.
Thanks to our AI-supported species recognition system, we can map the identified organisms in real time onto a geographic display, creating a dynamic marine life map for each location. We also collect and overlay key environmental data such as pH, temperature, and turbidity, offering a full ecological profile of the area. This turns our system into not just a protection mechanism, but also an early warning and monitoring tool. At the core of the BALLAST project lies an Arduino microcontroller. The entire system is integrated within the PictoBlox platform. We developed an artificial intelligence model using the Teachable Machine platform into a CSV file. This file is synchronized with Google Sheets and can be updated in real time. The data from CSV file is also visualized in real time on a custom configured Google My Maps interface. In this way, ballast water can be taken in without harming marine life, and potential threats to marine ecosystem can be identified in advance.
We are confident in the impact and contribution of our work to the marine ecosystem, which is why we have applied for a patent. Through this project, we aim to achieve four main goals: to keep marine organisms away from ballast water intake areas, to do so without causing harm to ensure the system can be adapted to any ship at low cost, and to reduce the negative impact of human activities on the ecosystem, enabling more sustainable ecological practices.
With BALLAST, marine ecosystems are safer.